Hey, this is the review for honors chemistry. Okay, you're going to have your test, and you're going to be responsible for all of Chapter 4. Now, I want to emphasize that the basic thing for Chapter 4, the emphasis is going to be on the sections of Part B that I didn't go over with you, and Part C. So those are the two sections, and I should be finished by then, but that's the whole point about this review. So let's go ahead and let's get started here. All right. Yeah, it's kind of useful to know the history. You should be familiar with like a one sentence. What did Democritus do? What did Lavoisier do? Proust, law of definite composition, absolutely. Dalton's law, okay. Volta, nah, I wouldn't worry about Volta. Okay, J.J. Thomson, sure. Okay, Rutherford, yeah. Okay, his experiment, what did we learn from the experiment? Yes, what did we learn from it? Okay, and understand that most of the atom's volume, it's very tiny. You know, most of the atom's volume is taken up by empty space. Chadwick discovered the neutron. Okay, what is the importance of neutrons? Okay, we talked about Bohr's model. We talked about what is it that Bohr suspected. Okay, he suspected several things. Electrons need energy and movement. That electrons go in places in different levels. They have different levels. We looked at spectroscopy. You should know what a spectrum is and the fingerprint of light. You should know the difference between a continuous spectrum, an emission spectrum, and an absorption spectrum. I'm going to emphasize more on the continuous and the emission. Now, really the difference between the two, continuous, all available light is put out. Okay? That's what we typically see. Now, the emission is only certain levels of energy are allowed through. That's the difference, okay? Emission spectrum, you think line spectrum, okay? What did we learn? Because of spectroscopy, Bohr was right. There are basic energy levels that are there, okay? Understand electrons. What are the three things electrons can do, okay? We talked about a little bit about de Broglie, a little bit. Okay, Heisenberg, yep, definitely would know about Heisenberg. What did he do? Okay, understand that. Do I care if he received the Nobel Prize? No. I'm interested in what was his discovery, what was his principle, and how did that affect modern day chemistry? Okay, then we look at where do electrons hang out. You should be familiar with the 4 pieces of address. Okay, which is summed up in this particular slide. Okay, again, your basic energy level, the shape of the sublevel or shape of orbital, the orientation in space, how is it that arranged in 3-dimensional space, and are the electrons spinning, and when they spin, are they spinning clockwise, counterclockwise, or what do they do? Okay, as we go through. Okay, now SPDF, yes, you should know this, that would be good. Now, am I expecting you to know the shapes of S, P, D, and F? Only the S and only the P, because the D and the F, frankly, they are a lot more complicated. Do I expect you to know how many electrons fit into every single orbital? Yes. Remember, Pauli mentioned about it, that's fair game. Two electrons for every one orbital. Okay, what does that look like? Well, we're right here on this particular thing. If you look there on the red one here, the red ball, that means 2 electrons at most fit in there. If it's 1s, it's 2 electrons. If it's 2s, it is also 2 electrons. If it's 3s, or 4s, or 5s, or 6s, or 7s, each one of them can hold a maximum of 2 electrons. That was Pauli who came up with that idea. Now, when we look at the D, the yellow underneath that red sphere, okay, there are 3 separate p sublevel orbitals in the p sublevel. Well, you'd say, what's the difference between them? The shape is the same, how they are arranged in 3-dimensional space. The x, the y, and the z axis. The D orbitals, I expect you to know that there's 5 of them, that they hold a maximum of 10 electrons. And the f orbitals, there are 7 orbitals, maximum number of electrons, 14. That, I would expect you to know that. This page I am not particularly worried about. Okay, we talked about the magnetic quantum number, about the spatial orientation. Okay, we talked about Pauli, the electron spin number. You should know why is it important that the electrons are spinning opposite of each other. Okay? So then we looked at what do these look like. Here's the s orbital, there's the p, there's the p, there's the d, and then here's the f. Okay? We're flowing through. Do I expect you guys to memorize this? No, I don't. You should be familiar with 1s, 2s, 2p, 3s, 3p, 3d, and then 4s, 4p, 4d, and 4f. That would be the most I would expect you guys to know. Okay? You should be able to know how many electrons go in s and d and p and f. You should know that. Okay? Understand the idea when you look at this slide here that the higher you go in those principal energy levels, the volume gets larger in size. Now I'm trying to hurry through this so I can get all of it down into one thing. Okay? Now, the order in which the electrons fill the sublevels. Guys, I'm looking at 1s, 2s, 2p, 3s, okay, 3p. Notice it goes to 4s, then 3d, then 4p, and then 5s. That's the extent I would want you to know. Okay? And then here on the periodic chart, we can look at this and say, oh, okay, oops, that's not the okay. On the periodic chart, what you're seeing there is what is the topmost level of all the electrons around that atom, and that's just the topmost, but what sublevel are they ending in? So, for example, we can look at number 11 here. Number 11 is the element sodium. Top level is 3. Top sublevel is 3s. Okay? Then when you're going and looking along on the other edge here, all these are 2p's, 3p's, 4p's. If you notice, it goes down in a nice, neat, orderly way. But when you get here to this column, ladies and gentlemen, you find that all the electrons are filled. They're completely full, and that makes them unreactive. Okay. Moving on. Off bow. Yes, you need to know this. Electrons fill the lowest available energy orbital. Period. The lowest available, that means empty, energy orbital. Okay? That's the key thing. That's why you're seeing 1s, 2s, 2p, 3s, 3p, 4s is less energy than 3d. Okay? It's easier to fill the 4s than it is to fill the 3d. When two electrons fill the 4s, then it goes and fills the 3d. Okay? Electron configuration, absolutely, you should be able to identify what does 1s1 mean. Okay? The 1 refers to the principal energy level. The second one is the letter S. That's the S sublevel, or sublevel S. And then the final one is the 1, which refers to the number of electrons in there. We looked at the helium here. If you look at helium, it is the same as the lithium, 1s2, 2s1, or He with the brackets. That means instead of us writing 1s2, we write He because we're saying, hey, the 1s2 matches the He, the helium, and then the 2s1. Okay? Electron configuration notation, I would expect to sit there and say, hey, I can give you sulfur, and it's got this many of electrons. What would the electron configuration look like? 1s2, 2s2, 2p6, 3s2, and so on. And that's it. Now, what about orbital notation? What's up with that? If you look at those up and down arrows, that refers to the spins, the opposite spins of the electron. Okay? Now, Hunds rule, really important. Okay, electrons fill a sublevel. All the orbitals receive one electron with the same spin before they begin to pair up. So I liken as monopoly. I will talk about that, the monopoly house rule. If you bought 3 houses and you have 3 pieces of land, each land has to have 1 house. You can't put all 3 on one property. In monopoly, it does not work that way. Okay? Just a quick thing for Hunds rule as I am moving on here. Okay? This is a picture that shows you the differences in the energy level. Okay? This is the picture that shows you the differences in the energy level. And if you take a look here, here's 1s, 2s, 2p, 3s, 3p. Now notice where 3d is compared to the 4s. 4s is just underneath the 3d. That's an important idea. That's why the 4s gets filled before the 3d. Okay, now I just gave you guys a very quick thing here for Chapter 4, Sections A and B. And that's going to be it for Honors Chem for your review. There is a second video that's going to specify more on Part C. And that way you guys have a review. Okay, this is Canu signing off.